Today we are going to look at our hypothesis testing process as a whole. So just to review before we start, our hypothesis testing is a procedure that enables us to choose between two claims when we have variability in our measurements. So those two claims are going to be our pair of hypotheses that we're looking at, and we're going to decide based on the information that's given which one is most likely true in the scenario that we're looking at. Right, so we're going to write our null and alternative hypothesis, and then we are going to find our test statistic, our z-score, and a p-value, and then use that p-value to make our decision about our original pair of hypotheses. So to just review our first four steps here, our first step is to state our hypotheses. So again, we're stating our hypotheses about our population parameters, both our null and alternative hypothesis. Then we're going to prepare, right? Get ready to test, identify our significance level in our problem, write down everything else that we may need to identify as far as different values in our problem go, and check our conditions required that we are close to a normal distribution in order to go through this process. Right? Then step 3, we're going to do our computations. Our computations can include our z-statistic, which we do have a formula to compute by hand, or we can also use StatCrunch to do, and then we're going to find our p-value, which we are going to, in this course, solely rely on StatCrunch to do. And then our last key step, right, the whole point of doing the problems that we're looking at is our interpretation. Right? Do we reject or not reject our null hypothesis, and what does that mean in this particular problem? Right, so down at the bottom of this page are a list for our steps for our hypothesis testing. The good thing is it's not much different than we saw in section 7.4. So we're going to go to our stat menu, we're going to select our proportion stats, we're going to select one sample, we're going to select with summary, just like we did when we were dealing with our confidence intervals. The only difference is instead of entering and selecting our confidence interval option, we're going to leave it as a hypothesis test. Right? We're going to enter our number of successes, we're going to enter our number of observations, we're going to select our hypothesis test, make sure we enter the correct number in for our hypothesis and the correct symbol in for our hypothesis, and then select compute. So I did write a little note here as we're thinking about these different steps, that when we are finding our number of successes, if it's not something that we're given, we're going to use n times our p hat, remember, which is the proportion that's in our claim. When we are entering our pair of hypotheses, we're going to make a little additional note here that we're going to want to make sure that we use our p naught for those values. All right, so let's go through the process of this problem. So in 2009, it was estimated that 63% of Americans supported the death penalty. In 2014, a Rasmussen poll found that in a random sample of 943 Americans, 538 supported the death penalty. Do we have evidence that support that the death penalty has declined among Americans since 2009? Use a significance level of 5%. All right, so like we did in problems in Chapter 7, we're going to start out by listing what we know. So our population is going to be all Americans. Our sample size is going to be the 943 Americans that were sampled. Right. Our P naught is our original percentage in the original question. So our P naught is 63%, so 0.63. Our P hat, in this case, we actually have to calculate it. So we're going to take this 538 divided by our 943, and we get 57%. Right. Our level of significance, we're told that alpha equals 0.05, so a 5% level of significance. Okay. Then looking at our question, what do we want to know? We are asked, has the proportion declined? Right? And declined meaning we're thinking about a less than symbol. So our first step, state our hypotheses. Right? So our null hypothesis, again, always has an equal sign. Right? So P equals, and we always use our P naught, our original value from our original sentence, original data. So P equals 0.63. And then our alternative hypothesis, we're going to use this symbol that we just saw here. So P is less than 0.63. All right, in all of the examples in this section, we're going to skip our conditions. We've checked them numerous times through Chapter 7. So in this case, we're going to skip our conditions, assume that all are met, and then we're going to go to StatCrunch to evaluate the rest of the information of the problems. And I will put step-by-step instructions on Moodle as well that shows the instructions for each different type of problem. So again, thinking about our StatCrunch instructions that were on the previous page, we're going into our proportion stats, we're selecting one sample with summary, we're entering the number of successes and number of observations, then we're selecting hypothesis test, and then in that portion for our hypothesis test, we're going to make sure that we change our percentage to 63%, and that we're going to change this symbol to a less than symbol. After we select the compute button then, StatCrunch is going to give us some different values. Right, so we'll start with our z value. Our z is going to be negative 3.82. Z-scores we almost always round to 2 decimal values. Right, so that's going to be a z-score of negative 3.82. Our p-value that we're looking at. Our p-value in that box on StatCrunch in this particular case, it's going to say that p is less than 0.0001. Right? What that means is our p-value is very, 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 very small. Right? So as we're thinking about that, our p-value is very, very close to 0. Right? When we're putting things in StatCrunch and we're checking our conditions, just a friendly reminder from our steps on the previous page that when we are checking our conditions, we always want to make sure we use our P naught, which in this particular problem is 0.63. Okay. And in this case, we are actually given our number of successes. We were given 538 out of 943. But if that's not the case, remember that we want to use n times our p hat, right, if needed. Right? So in this case, our p hat is that different percentage. Right? So just as you're going through these problems, pay very careful attention to which is labeled which you're plugging into each formula. All right, then to make our decision, right, we have 2 different criteria that we want to look at thinking back to the last section. Right? And it's worth kind of showing this page again. Again, on page 9 in your notes, this is the key to every single decision and problem that you're going to work through this semester. Right? We're going to reject our null hypothesis if our p-value is less than or equal to alpha, and we do not reject the null hypothesis if p-value is greater than alpha. Right? So if p is less than or equal to alpha, we reject. Right? If p is greater than alpha, we do not reject. Right? So put this on a post-it note, write this on a sheet of paper as you're working through their homework problems. This is how you're going to make all of your decisions for this entire chapter. Is p less than or equal to alpha, then we're going to reject our null hypothesis. If p is greater than alpha, we are not going to reject our null hypothesis. All right, so looking at our particular problem. Right, so our p is 0.0001. Right, so 0.0001 is less than our significance level. Right, so our p is less than alpha. Right, so going back to what we just looked at on the previous page, since p is less than alpha, right, that means that we are going to reject our null hypothesis. Okay. So we're going to reject our null hypothesis because p is less than alpha. Okay. So going up to our statements here, if we reject our null hypothesis, Okay, I'm going to go ahead and cross this statement out. So that means that that statement cannot be true. Okay, so what that means is, by default, our alternative hypothesis should be the one that is true. Okay, so we're going to say we can conclude that support for the death penalty has declined in Americans since 2009. Okay, so based on what we have circled up here, it's no longer equal. Our proportion has declined. All right. Let's go through a couple more examples. So suppose a poll of 250 randomly selected voters in a city found that 140 of them favored increased funding for public libraries. Based on this poll, could we conclude that a majority of the voters in the city, more than 50%, favor increased funding for public libraries, use a significance level of 1%? So we're going to start by listing everything that we know. So our population is going to be all voters, right, in the city that we are looking at. Right? Our sample size is 250. Right? So 250 voters sampled. Right? Our P-naught, what we're testing against, right, is we're testing whether or not we have a majority. We're testing against 50%. So this is going to be 0.50. Right? Our P-hat is our 140 out of 250. Which if we switch that to a decimal, we get 0.56. Okay. Our level of significance, we're told to use 1%, so alpha equals 0.01. Right, what we want to know, okay, is the population is a population proportion, I suppose I should say. Is the population proportion the majority? Right? Majority meaning larger than 50%. Right, so we start by stating our hypotheses. Our null hypothesis, P is equal to our P-naught value, so P equals 0.50. Our alternative hypothesis, using what we're looking for, P is greater than 0.50. Right, again, for step 2, we're going to skip our conditions. We're going to jump right to StatCrunch. So in this case, if we go to StatCrunch, we enter our number of observations, our number of successes, and enter the correct null and alternative hypothesis. Then we get a z-score value after we select the compute button of 1.90. And we are given a p-value of 0.0289. So what we then want to do is we want to compare p to alpha. So 0.0289, our alpha is 0.01. In this case, p is greater than alpha. P is greater than alpha means we are going to not reject our null hypothesis. So going up to our pair of hypotheses, we are not going to reject our null hypothesis, which means we're going to cross out our alternative hypothesis. And when we're answering our interpretations at the bottom, we're going to refer to our alternative hypothesis because that is the claim that we are testing. So we crossed off the fact that P was greater than 50%. So we are going to state we cannot conclude that the majority of voters supported increased public library funding. So we cannot claim that the majority supports this, right? It could possibly be equal. So since our P was larger than alpha, right, we did not reject our null hypothesis. All right, now one final example for section 8.2. A group of medical researchers knew from previous studies that in the past, about 39% of all men between ages of 45 and 59 were regularly active. Because regular activity is good for our health, they selected a random sample of 1,927 men, and 680 said they were regularly active. As the proportion of physically active men in this age group declined, right, use a significance level of 5%. So as we did in the previous problems, as we did back in chapter 7, we're going to start by listing what we know. So our population is all men ages 45 to 59. Our sample size is the 1,927 men in this age group that were sampled. In the past, 39% said that they were regularly active, so our P naught is this original value of 39%. Our P hat, 680 out of 1,927, which gives us a percentage of 0.353. Right, level of significance, we're told to use alpha equals 0.05. Right? And what we are looking for, right, the question we are being asked is, has the proportion declined? Decline meaning a less than case. All right, so to state our hypotheses, our null hypothesis always starts with an equal sign. So P equals 0.39. P equals P naught. Right? Has this declined? Well, P is less than 0.39. Again, we're going to skip our conditions in this particular example. We're going to go to StatCrunch. Again, we're going to make sure we enter our number of successes, number of observations, make sure that we put our correct pair of hypotheses in using this 39%, and we get a z-score of negative 3.34. Right, our p-value, 0.0004, so another very small p-value. Right, so if we compare these, 0.0004 is definitely less than our alpha, which is 0.05. Right, since p is less than alpha, we are going to reject our null hypothesis. So going back up to our statements, that means we're going to cross off our null hypothesis and circle our alternative hypothesis, and we are going to say we can conclude that the proportion of men ages 45 to 59 who are regularly active regularly was smaller than in the past. Alright, so again, we set up our pair of hypotheses. We skipped our conditions again, which you will for the most part in these questions. We found our z-value and our p-value using StatCrunch, and then based on those we made our decision to reject our null hypothesis because p was less than alpha, and then we wrote an appropriate conclusion as a sentence at the end of our problem.